Your height is not a limitation. It is a biological performance profile, and right now, you're probably using it completely wrong. There are 6 distinct height ranges in women's athletics. Each one archives a different physics advantage, forged by a completely different set of survival demands. By the end of this video, you will understand exactly which sports your body was built to dominate. You'll see why certain female athletes aren't just talented, they are physically inevitable. Let's decode yours. Because once you see the physics, you'll realize your weakness was actually your greatest weapon. Under 4 feet 11, the rotational engines. The secret weapon here is something physicists call angular velocity, but you can just think of it as the spin cheat code. Think of a gymnastic tuck. When a 4 foot 9 inch athlete pulls her knees to her chest midair, she is transforming her entire body into a high-speed projectile. She didn't get stronger, she just got more compact. In the world of physics, compactness is the weapon. At under 4 feet 11, your limbs are already sitting close to your body's rotational center by default. When you tuck, you reach a tighter shape than a taller body can physically match. Asking a 5 foot 8 gymnast to out-rotate a 4 foot 9 gymnast is like trying to spin a broomstick as fast as a pencil. The geometry simply will not allow it. That compact frame means shorter limbs and less stride length. Distance running and open water swimming skew toward taller frames for exactly this reason. This engine was built for the air, not the open road. Nadia Comaneci, standing under 4 feet 11 and weighing just 86 pounds at the 1976 Montreal Olympics, she didn't just win, she broke the sport. She became the first gymnast in history to receive a perfect 10.0. In fact, she got 7 of them. The scoreboard wasn't even programmed for it and flashed 1.00 instead. Her competitors weren't less dedicated. They were just carrying more mass farther from their rotational center. Physics made the gap, not effort. The hidden advantage here is rotational speed that taller bodies cannot replicate. Gymnastics, figure skating, diving. Any sport where the tighter your tuck, the faster you spin, and the faster you spin, the higher you score. But rotation is only one weapon. What happens when that compact build stops being about spinning and starts generating force that nobody your size should be able to produce? 4 feet 11 inches to 5 feet 1, the compact force generators. The physics shift here is torque efficiency. Think of tightening a bolt. A short wrench needs less travel to complete the turn, while a longer wrench has to sweep a wider, more exhausting arc to move the same bolt. At 4 feet 11 to 5 feet 1, your limbs are the short wrench. Every jump and every push requires a shorter path from the load to the joint. Your body doesn't waste energy sweeping wide arcs. It fires with minimum distance and maximum output. This is pure, concentrated power, like a high-performance engine in a compact car. That short lever means less reach. In sports where arm length determines strike distance or swimming pull, this frame works against its own design. The short wrench drives bolts perfectly, but it can't reach across the room. Shelly-Ann Fraser-Pryce. Standing at exactly 5 feet flat, they call her the pocket rocket for a reason. In a sport dominated by long striding giants, she has won 8 Olympic medals by simply being more explosive. Her legs are the short wrench. She doesn't need a wide, sweeping stride to generate power. She hits the ground with more force per pound than her taller competitors, reaching her top speed while they are still trying to overcome their own inertia. The hidden advantage is explosive power at a force-to-weight ratio longer frames cannot match. Gymnastics, weightlifting, combat sports, any discipline where the distance between your joints and the load determines how much power actually reaches the ground. From raw compact force, the advantage shifts. What if the edge isn't about power generation at all, but about something faster and more elusive? But even this explosive power can be completely neutralized by the final category we'll cover, the frame that doesn't just play the game, it rewrites the physics of the entire court. 5 feet 2 inches to 5 feet 3 inches. The agility architects. The physics concept here is inertia. Inertia is just your body's resistance to changing its state of motion. The more mass you carry, the more force it takes to stop, start, or change direction. A 5'10" defender has to fight her own momentum to redirect. But at 5'2" to 5'3", you have enough leg length for a powerful stride without the heavy mass working against you. You can stop on a dime because your dime is physically smaller. In sports built on direction changes, that difference compounds on every single touch. Gabby Douglas. At 5 feet 2 inches, her routines demanded positional resets so fast that by the time a taller competitor had even finished slowing down from the previous movement, Douglas was already loading the next one. Her opponents weren't slower athletes, they were just paying a mass tax on every single transition, a tax that she didn't have to pay. Elite direction change speed. Court sports, martial arts, and field sports. Any arena where changing direction before your opponent can react is the entire competitive edge. A frame optimized for quick starts, and stops pays for it in raw top-end speed. Over a straight 100 meters, longer legs will usually win. The agility architect wasn't built for the straight line. She was built to make sure you never get one. Look at your hands right now, then look at your legs. Which one of these first 3 profiles just clicked for you? Drop your height in the comments. We are halfway through, and the next 3 ranges are where the geometry gets significantly more interesting. Because while the agility architect is about the speed of the move, the next range is about the speed of the mind. 5 feet 4 inches to 5 feet 5 inches. The ground readers. Your center of gravity sits close enough to the ground that your base loads with absolute precision. Think of the difference between a sports car and a truck. The lower the center of mass, the more efficiently the vehicle reads the road. At 5 feet 4 to 5 feet 5, your body loads the ground the way a Porsche corners, with sensitivity, speed, and the ability to change your line before a larger athlete has even begun to react. At this height, your feet don't just touch the ground, they interrogate it. While taller athletes are fighting their own center of gravity, you're using the surface as a tactical launch pad. That same ground-hugging efficiency becomes a liability when reach overhead is the only thing that matters. The ground reader owns the surface. Everything above the net is someone else's territory. Marta. At 5 feet 4 inches, she dominated women's football for 2 decades, scoring more World Cup goals than any player in history, male or female. She faced defenders who were taller, stronger, and faster in a straight line. None of it mattered. Her ability to read the surface and change direction made her structurally unguardable. Her competitors weren't lesser athletes. Marta's body was simply operating in a more efficient mechanical window, ground reading and sustained agility. Football, basketball, field hockey, any sport where reacting to the surface under your feet faster than your opponent determines who controls the game. What happens when that ground efficiency scales into a frame that adds reach, endurance, and power without sacrificing any of them? The next group has a biological golden mean that makes them the most versatile athletes on this list. 5 feet 6 inches to 5 feet 9 inches. The all-rounder zone. In biology, there is a concept called the golden mean. This is the point where a system isn't optimized for one extreme, but for the broadest possible performance across all conditions. At 5 feet 6 to 5 feet 9, that is your body. You aren't the tightest rotational package, and you aren't the shortest lever. Instead, you are the closest thing to a perfectly balanced athletic machine. Even your heart has it easier. It doesn't have to strain to pump blood to distant extremities the way a 6-footer's does. Essentially, you're the decathlon athlete of biology. You aren't just good at everything, you are efficient at everything. Serena Williams. At 5 feet 9 inches, her game wasn't built on just one physical weapon. It was built on the ability to serve with power, cover the court with endurance, and place the ball with surgical precision, all in the same match for 20 years. That dominance doesn't come from specializing. It comes from a frame that doesn't have to choose between weapons. Invisible versatility. You've probably never had a coach tell you your height is your advantage because it doesn't look like a cheat code. It just looks like everything works. But even the most balanced machine can be completely shut down by our final category. What happens when pure vertical dominance starts to override every other variable? 6 feet 0 and above, the environmental force. Every height range we have covered deploys a specific physics weapon. This range does not have a weapon. It is the environment. At 6 feet 0 and above, the concept is called total spatial takeover. Your physical presence alone forces every opponent in the vicinity to alter their own body mechanics just to function. You do not adapt to the game adapts to you. Think of a standard basketball shot. It's engineered around a specific arc and trajectory. That math works fine against a 5'9" defender, but against a 6'9" center with a wingspan exceeding 7 feet, the equation breaks. The shooter has to change her arc, slow her release, and shift her footwork, all while under pressure. In this case, the defender didn't just block the shot. She edited the shooter's mechanics before the ball even left her hands. Brittney Griner. At 6 feet 9 inches, she is the WNBA's all-time leader in blocked shots. Her wingspan exceeds 7 feet, creating a defensive perimeter while standing still that most players couldn't replicate at the peak of their jump. Opponents don't just have to beat her. They have to solve a geometry problem she poses simply by existing on the court. A frame this far outside standard dimensions pays a tax in every system the sport wasn't designed for. Recovery protocols, equipment, and even simple travel. None of it was built with this body in mind. The environmental force rewrites the rules, but she also has to operate outside of them. The hidden advantage here is Spatial dominance that rewrites tactical rules. Basketball, volleyball, rowing, any sport where your presence forces opponents to change how they play before the contest even begins. 6 height ranges, 6 completely different athletic blueprints. Now look at your team. A ground reader, an all-rounder, and an environmental force together aren't just athletes, they're a perfectly balanced evolutionary unit. None of these is the best height. Each is the best height for something specific. The only question is whether you are training in the environment yours was built to dominate. Drop your height in the comments and let us know. Did your superpower just click? I am Noah, and I'll see you in the next video.